Good afternoon, everybody. My name is Tom Nato, and I'm co-host of the Net.lol podcast. I'm joined here today, as usual, with my co-hosts Kyle Mestery, or Kyle Meshery, Dave Tucker, and Brent Salisbury. And thank you all for joining us today. Today we're joined by our esteemed guest today, Hannes Gredler. Hannes and I worked together at Juniper for a bit and lots of IETF stuff before that. Hannes is the principal at a new startup called RTBricks, and we're going to be talking about virtual routers, the changes in the network industry today, and everything in between. So Hannes, welcome to the show. Could you introduce yourself? Tell us a little bit about
Thanks
yourself.
for having me, first of all. Yes, short introduction about myself. I've been supporting and selling and messing around with routers for 20 years. I always tell my wife I'm of no use for anything else, right? So I started to do that 15 years, I think, at Juniper Networks totally. And after 15 years, we saw a bit of unnerving trends in the networking industry. All those hyperscalers on the US West Coast, they start to build and procure their equipment directly by themselves, right? No need for system vendors like Cisco or Juniper. And my product manager at Juniper, Praveen Bandakar, which later on became my co-founder, we were just asking ourselves, at what point is that wave of disaggregation going to hit the telco market? That's how it all started.
Yeah, and it has hit in a tidal wave kind of way, right? Yeah, I mean, one of the things you mentioned that's interesting to talk about is maybe to rewind a couple years when you started RTBricks. I mean, it was, what, 3 years ago?
We started actually in 2015. I mean, if you look back in 2015 was a pretty interesting time because all the major networking and routing stacks have matured to a very, I would say, a difficult age, right?
Very little had changed at that point, right?
Yeah, when the stack gets between 15 and 20 years, a lot of life support, love has to come into it, right?
Well, and a lack of new things, lack of innovation, and at that point, that's when you start noodling around the edges. And I read a really cool blog yesterday, and I of course forget who it was, but maybe we can paste it in later. But the quote from the blog is that you should really think carefully about rewriting your code, because when you get to that point of rewriting your code, you lose the context of all of the changes that happen. And we worked on Junos. I mean, there's a billion changes to that code base, right? And when you get to the point of where you are now, where it's a mature code base and there aren't new things really being added to it, you wonder, like, you hope that, the next move isn't to go start rewriting big chunks of it, although that is not to pick on Juniper, but like everybody is doing this. They're rewriting their stack so that they can work in the same stack, maybe in a cloud environment, a container native environment. I mean, what are you seeing in that kind of area?
So first of all, it is kind of funny to me that in every a business, right, you put in some reserves for the unforeseeable, right? Pensions, any stuff, right? However, in the software industry, you do not actually put any money aside for refactoring work. Yet anybody knows it has to occur. So we are really good at this new architecture is so fancy, right?
In
We
the
don't
U.S., it's
really need
called
to
kicking
put
the
in
can
any
down the road.
incremental investment. Yeah,
Yeah, we'll do
exactly.
it later.
We do it later, right? And then after 10 years or so, right, you're almost begging your senior VP, hey, I need some money, right? This infrastructure is rotten down to the core, right? Let's
Yeah,
rewrite it, right? And that is a bit the issue, right? There is not careful planning. I'm sure you guys know about that famous Steve Jobs commencement speech, right? Where he watches life from the back, connecting the dots from backwards forwards, right?
yeah.
And same thing here, a software life cycle. Think about it, how to put it to rest, how to bury it, right? How to replace it, right? What are the change agents of software?
Right.
Uh,
What is the modern context in which it needs to live? Like the containerization, and as everyone here knows, containerization of an existing workload that might be running as a VM or a PNF even is not trivial, right?
Well,
I
and I
mean,
think the other thing is it's not just which one, but when, Hannes, as you're saying, when do you kind of like put it to rest and start over rather than drag it forward from physical to virtual to container to serverless to, when do you make that decision and how do you do it in an efficient way and start fresh?
I mean, I guess you guys at Red Hat, you certainly have more experience than me on that matter. But
Kyle isn't at
the
Red
really,
Hat, by the way.
the,
Kyle's at
oh,
Cisco.
not everybody's Red Hat. Oh,
No,
That's
no.
no,
right. Not
Kyle's at
everyone's.
Cisco.
No, this
But
isn't a Red Hat podcast.
okay,
Yeah.
okay, okay. So, so I guess that's one thing that we should cut out.
No,
Sorry
we're
for that.
leaving
It's
that
all
in. That's
good.
for comic. Yeah.
All good.
No, no. I think the difficult thing here is really going from the monolith to microservice, right? And most often that is not very easy possible, right? People just think, hey, we have now this nice monolith. It does things at the defined performance. It takes in BGP routes. It programs forwarding tables, right? And once you sort of try that port that over to your fancy container-based system, and you have, I don't know, a 2 dozen subsystems wildly talking to each other and REST calling each other. Hey, performance really sucks, right? You end up at forwarding table update rate of, I don't know, 100 routes per second, right? So that's a bit the hard thing.
Yeah. Well, one of the interesting things, and you guys, feel free to comment on this too, like kind of the direction Hannes is talking about is the way I'm looking at it is, excuse me, what a lot of route stacks have done is when they rewrite the stack, they take the opportunity to delete old stuff. Like we don't need to support Apple Talk anymore. We don't need, all of that crap that's been in there for 15 years that literally no one has turned on. It does have an effect of shrinking the thing down and maybe and by doing so, maybe it's, more reliable for one, and is a smaller footprint. So it's actually cheaper to execute, and operate. And that gets into a bit of your virtual router area, Hannes. I mean, is that what you guys have done? Is started with a small kernel or a big thing?
What we have at RT Brick is precisely that thing, right? We thought, okay, there needs to be a way to get old code out of the system because that is really the heart of the matter, right? At larger vendors, they have that nicely crafted monolith, right?
Mm.
And the product management has almost no clue whether that code is still in use somewhere, right? You have no way of tracking it. Nobody is certain if you can remove it at all. So
hmm
we thought,
That's usually the way you figure that out is you remove it actually, and then you
yeah,
listen for the
yeah, and then you
screams,
have your SVP of customer service calling your names, right? Of course, yeah.
Right? Who took that feature out?
So yeah, I mean the thing is really obvious, right? You basically have to converge to a plugin-based infrastructure where you just say, okay, we just develop here a core nucleus, event loops, databases, IPC, fast message buses, right? And actually, the code should actually be rather small, usually units 25, 30K lines of code. Certainly something that, if it doesn't prove to be valuable, right, can be dismissed anytime, right?
Without wrecking the whole infrastructure. And
Exactly.
that's an
Exactly.
interesting kind of area, right? So as you're architecting this thing, your architecture for, your plugin based architecture is kind of, I look at it kind of like a circle with like the Linux model where you have a kernel and things plugged in around it that can get plugged in or unplugged in, plugged in or unplugged in while the system is running, while it's fully forwarding traffic, doing its thing. And it won't disrupt the system, or it might, but in a very well-known, very specific
Localized.
way.
Yeah.
Yeah.
Sounds
So
to me
that's
like you're
cool.
describing eBPF, Tom.
Yes, yeah, I know that's where it's
Yeah,
going.
yeah. Whether you call it eBPF or Linux loadable kernel module or just the dynamic linker, right? Using DLOpen and DSIM, and I mean those concepts there in the Unix code base for 3 decades now, right?
Decades. Yeah.
So yeah, so let's start really using it, right? At last.
Yeah, so that must be interesting because, like you and I have worked on the previous monolith kind of model that's so tightly glued together. And,
I,
you know,
I tell you a
well,
nice story at at Juniper. We had once a problem. Peter Lofberg, right?
hmm
Which has joined DT at that time. Was selling his idea of TerraStream, and one really beautiful showcase was that thing where you just bend the fiber before it breaks, right?
hmm
And then the router really has to proactively reroute the traffic around that such that when the fiber finally breaks, right, there is zero packet loss. How is
Yep.
that possible? Well, when you bend the fiber, the optical receive levels, right,
Should
go
start to
through the roof,
change. Yeah.
right? That's sort of a window, 100, 200 milliseconds where you still can do things.
Yep.
So now we had that situation where we had just one small driver component who was measuring those receive levels, and it needed to do things to convey that a scalar to the routing code. You would think easy thing, right? Microservices architecture, I just put it on the message bus, ship it. Even if you don't have a microservices architecture, you just have a REST call somewhere.
Somewhere.
However, in that monolith, communicate any-to-any communication is not that easy, right?
Yeah.
So the
Well,
driver
and it's
talks.
also it's very brittle, right? So
Yeah, yeah.
I won't
Also,
pick on a specific example, but like a one lost message, on let's just say like you're doing a broadband subscriber, authentication and registration, one lost message out of the 500 messages that actually have to get sent around in that kind of system will completely derail that state machine because it's so hyper optimized, and it was done rightly so to squeeze all the performance out of the little uh, computing power we had at the time that
and
now it sounds kind of
and
ridiculous
and
to
and
bind it
and
that
and
way.
and that over optimization is, I would say, here really the root of that evil, right?
Yes, yeah,
Because when we started this, we have been working with Pentium 1, Pentium 2 processors with
yep,
256 megabyte RAM as control plane CPU, holding full table routes, right?
yeah,
And every development team had to squeeze out every kilobyte, right, to not really,
every
uh,
cycle. I
um,
mean, we were still writing
yeah,
assembly code to try to
exactly, exactly.
the compiler, GCC was not clever enough. We knew better and had to write our own,
And today, GCC, that's what I tell my developers, don't try to outsmart GCC, right? He does optimization far better than you, right?
right, right.
So, and yet today we have CPUs by 3 orders of magnitude more powerful,
Yeah,
memory almost 5 orders of magnitude.
and
And yet
the
you
bus
look at
between those
the
things
micro optimizations.
is so much faster too. It's almost like, in fact, it's funny because I look at the architecture today, the Intel architecture, and it's a lot like what we built in at Cisco and Juniper in those kind of bespoke forwarding boxes, right? It's the same sort of thing. Like the NICs or line cards have
Mhm.
full-on CPUs on them now. Can run a whole Linux distro on them now and do basically what our line card processing could do 15 or 20 years ago. And that's how we did nonstop routing and all those things, right? But
It's dumb that architecture is a little bit like miniskirts, right? Every 20 years it comes again, right?
yeah, exactly.
So,
And it
so smart NICs, right? Same thing here, right?
Same thing, yeah.
Yeah.
If you scratch the label off of the thing, I've got a CRS-1 CPU here, the first generation one when I was at Cisco, and I
Okay.
still look at that thing and I'm like, wow, how much did that thing cost and what could it do? You know,
Yeah, yeah,
I mean in NICs from Intel and Mellanox or whatever, put that thing to shame today.
yeah. Hmm.
But the point is that it's like a full machine is on all the cards. So now a server looks like you said your miniskirt example. What a whole an MX looked like 20 years ago or whatever, and or
I mean, have a look at SmartNIC designs, right? They're usually, massive parallel CPU cores with some networking glue
yeah,
on the same die.
with big
That's really
lanes
what it is.
between everything.
Yeah.
Well, they're also designed by the network people that worked across the street, so that's why they're
Yes, yes, yes.
cool, cool.
So
Um,
Hannes, so you've got this modular architecture. Are you leveraging that by loading protocols? I'm kind of from a user perspective, does that give the ability to kind of load in and load out specific protocols? So
Exactly,
now you've got a
exactly.
lighter weight.
So, as Thomas pointed out, containerization comes here with a couple of constraints, right? It's not just endless opportunities, I'm afraid. One of those constraints is that you're inheriting the kernel, right? So you cannot really use the kernel for any application level stuff like propagating forwarding state to your line cards, and many people do it like that way, right? Same thing here all over again with Sonic, right? And coming here a bit from a company who has done that and done also the suffering from that design consequence. I thought, no, I just don't want to do that. So basically, every component, whether it's routing protocol code, data store, configuration store, any young translation gateways, routing protocols, forwarding table, abstraction managers, all of it, right? User space. Very simple answer.
so that
Gives also, as a developer, the nice advantage, right? You can just live attach your debugger and immediately figure out what is going on. You don't really need to hire expensive kernel expertise and all of that.
that's way easier to develop. But so is that because of your that's directly related to your plugin model? So you can you can
Absolutely,
keep the form
absolutely.
factor small and you don't have special debugging tools and so on like we used to. You don't have to have any pods or anything.
It's down to the point where we don't use the Linux kernel at all, right? So in the RT-Brick container, if you actually do your IP link show command, right, you don't see anything except that interface that points you out of your container, right? Because the interfaces are just a sort of a logical construct, right, in the database, purely driving the ASIC machinery. Of
Yeah.
course, if you want to have, let's say, in-band traffic, we can sort of punt that out. But in general, we just keep the router almost as a closed application here.
Cool. And is your forwarding actually happening at the CPU or is it on the NIC?
Both ends, right? So basically, every router has also a host personality, right? For that host personality, we're using FDIO VPP
Yeah.
Purely to get the L3 traffic across many routing universes in and out of that box,
Oh, cool.
with all the different tunnel flavors, MPLS, VXLAN, it's all in there. But we don't really use it as a sort of a high-speed x86 forwarder. For us, it's purely Dave Barak doesn't like that, but it's purely a host path forwarder.
So it's more like a punt path
Yes, yes,
than a.
exactly. And basically preparing the forwarding stack and serializing that down to the particular chip vendor's SDK, that is also, again, a user space application.
Cool. Let me see. Tucker, do you have any questions? I don't want to. Make sure you guys have room to ask questions in here. I don't want to.
No, it's, it all sounds really good. I'm kind of curious on the, so you mentioned about performance and the, with CPUs as they are, you can pretty much do whatever you want now and you don't have to worry so much. I guess the corollary to that is that Moore's law is starting to taper off, right? Where we're not able to go much smaller and carry on doubling the number of transistors. We're going to end up with perhaps more power efficient things, but at some point, the CPU that we have available to us is going to be finite. So does that mean we do need to go back to optimizing things in assembly, or are we okay to rely on the compiler?
No, Dave, I don't think that's happening. You're true. With single core performance, certainly we see Moore's law tapering off, right? However, what we see is more and more cores, either on the same die or sort of federated CPUs. And that is a bit of a nasty thing if you're coming here from trying to make your monolith work in such an environment, right? Sort of porting forward and sort of breaking up single core, highly optimized code for a multi-core environment. That is really hard. Right.
Well, not just multi-core on the same CPU. The other thing, one of the things you mentioned earlier was around, we didn't dig into it, but maybe you can get into that now, is the evolution of NPUs, right? Off-the-shelf NPUs, no less. I mean, the stuff from Broadcom and those folks is incredibly fast.
I would even go one step ahead, right? When we look here a bit on second generation routing OSs, they have a very strict layout, right? So here is, 1 to 8 line cards that talk to the routing engine, and here is the routing protocol code. And if you ever try to move things around and say, hey, look, can we just, spend that portion of routing protocol code, BFD, whatever, just move it to the line card? Hey, wow, it's, or it has been in the past a 2-year endeavor to do so. So I found that always a bit strange. Shouldn't it be like, hey, I have several actors and sensors within the box, right? And then they figure out how to properly share and exchange information. And placement, in fact, should not matter, right? Wherever it's convenient or where you have some hardware resources left, which are best for the job.
Yeah, because otherwise that harkens back to, again, this bespoke hardware architecture we had. For example, multi-chassis stuff we did with.
What a disaster!
What a disaster, right? But it was brittle because of what you just described. Like you said, well, that line card, if you're going to do multi-chassis, has to be the special one with the special connector on the back and the yada yada yada, or nothing works, and. It's that's kind of what you're describing. Like, you want the freedom to mix and match, not, and have it still work. It's interesting too. We talk about NPUs, but now we've got lots of other specialized processors, and maybe that's how we scale the parallelism of, we've got NICs that have ARM processors on them now, DPUs. Et cetera, radio controller processors. We're starting to see the commodity server turn into yesterday's networking equipment, effectively.
I found that very interesting because at a certain time, I don't know, 10 years ago, hardware was not much of an exciting thing, right?
Yeah.
All the cool kids were doing software, right? But now, if you actually look what's happening today, Amazon, Graviton, all doing their ARM cores, right? Highly specialized, very optimized for typical workload. So it
Yeah.
looks like now hardware is cool again.
Well, at some point, after all the virtualization smoke clears, there's got to be some hardware down there. The
Yes,
cloud has to
I always
somebody
run
find
on
it
has
it.
to
funny.
do the work, right?
Right.
Yeah, it's like what we used to call smart NICs will just be NICs tomorrow,
Just
right?
NICs,
Like
and
eventually
then we'll
it
call them
just creeps
interface
in from
cards.
economies of scale where it's going to be implicitly there.
Well, I feel like
Everything
we're also
accessed through Kubernetes with added service mesh, it'll all be fine.
no. Let's not go there because at some point the cost of all of those layers of abstraction is going to come due, right? I
Yeah.
think that's what people don't realize. I mean, all of these giant stacks of abstractions are not free, despite what the marketing material may tell you. So yeah, maybe there's some room. Who knows? Maybe we'll have, hardware offloaded Kubernetes in the future, and I can't believe I just said that. But
Well,
You
at some
did.
Oh my
point,
God.
at some point, it's the same movie, right? We run it in software and we figure out how the thing works. Then we kind of optimize it and go, hey, what if we accelerate? What if we build hardware that can do the generic thing? That makes it, an 80% cheaper and 80% faster. It is. I mean, we did this many, many times across the history of all of the stuff we've been working on, right? And it's kind of, we're just in the next iteration of this where oh yeah, all that stuff was in software. Now let's put it into NPUs. We've been doing this. It's just now the NPUs are many PUs, not just NPUs, right? There's DPU, there's blah blah blah, right? And but the interesting thing is what Kyle said is the technical debt that's created with the monster systems that need to understand how to control and interface these things to like containers, for example, and then getting the same high performance experience in the container through all of the overhead between the container and the piece of hardware. That's where one of the tricks is today, right? And the question is like back to you, Hannes, so if you're up in container land, how are you handling that? Are you doing horizontal scale, or you have specific hardware interfacing you're doing, or what do you tell us about the black magic?
Actually, we fought in the early days, 2015, 2016. We fought really hard about how to get that, and we ended up how to get it right, and we ended up as just using one container, right, which actually holds all of the daemons that you need. To build up here a routing subsystem, including CLI and management plane, mostly because we just wanted to solve, I would say, a dependency problem, right? In the hardware OEM space, everybody comes with different flavor, right? So there is Open Network Linux, then there is a sort of a bare bones Sonic distribution. Yet another one comes, I don't know, with Wind River Linux. And what we wanted to do to be successful here in the disaggregated space is we needed to solve the portability problem, right? So how can we actually run our software at pretty much any guest OS, right? Of course, we could put on a heavy VM or so, or we could just use here container as a sort of a para virtualization technology purely to decouple ourselves from any dependencies we have on the host OS, right? And that's really how we did it, right? So we focused here on that plugin system, making the code base really small to a point where we can just throw away the plugin and commence a rewrite. And number three, solve that dependency problem.
Cool. So
I like the microservices blasphemy there because it offloads a lot of the kind of container runtime management issues too.
The container runtime is also an interesting one. So we started a bit with LXD, LXD 2.0, and we figured out, hey, that's sort of great for doing normal server workloads, but for a telecommunication product, there is actually more needed, right? Because you need to have in-band communication access into the container. So that sort of a container runtime also becomes a sort of an API gateway in and out of the container. That's number one. Number two is for in-service software upgrades, for shutting down a container, for bringing up a container. You need to have almost like an ordered protocol where you gracefully remove yourselves, you close your BGP peers, you close your subscriber management sessions, then gracefully remove yourself, start the new incarnation of your software, and then quickly 5-6 seconds thereafter, you're back into the game, right? Which is usually the much more faster operation, whether we would just squash down the old container and bring up the new one. So we had to basically teach here the container runtime a few new tricks.
Oh, cool. Yeah, and it's interesting how you solved that, because that's usually, a really scary and thorny problem, right? Is the ISSU thing with containers today, the typical approach is stand up a new cluster, stand up a new application, kill the old one, and everybody's good.
Mm-hmm.
But if you're controlling infrastructure, you need a synchronization thing and a predictability to that. You don't want to just go poof. There go all my BGP peers. Wait for the next one to come up. That's not how it works. So you don't want to just lose that. So is that how you guys are doing horizontal scale? You bring up different, you just bring up 2 containers instead of 1, and maybe on a different piece of hardware?
No, that's not how we're doing it. Basically, we, rather than trying to overcomplicate, I would say, the redundancy solution by adding, expensive replication of stateful protocols and all of that, we just really focused on really speed tuning, making sure that the container downtime when we restarting, kiss goodbying everybody and restarting is actually very short, right?
It's just to
Including the
minimize.
chip initialization time. You know it, Tom, right? We've seen it in previous life. All those non-stop routing and things. Ooh, very.
Well, that's what I mean. That is like some of the most complicated black
It's an
magic I've ever seen in engineering.
eternal text to software, right? And I was pretty certain that I didn't really want to repeat that mistake. So really keep the software very lightweight and make sure that all the components really boot blazing fast, such that yet again you're minimizing your downtime. Problem solved.
Cool.
Hans, what are some use cases for folks listening out there? I'm curious. Are you focusing on edge? Are you focusing on?
We actually have started originally with the classical virtual route reflector environment because we had all the horizontal scaling capabilities and all of that, and we thought that in the data center market we would be welcome with wild success. It turned out that the data center environment is a very overcrowded space.
Yes.
So there we are, startup founder in your second year, and we very quickly found then another interesting market where we could pivot into, which is essentially on the network edge, on the what previously has been a broadband networking gateway, because we saw a lot of activity in that space.
Oh, interesting.
Service providers were looking into like, hey, can you run your software on my GPON OLT? Yeah, of course,
So
the
a small
software is
form factor
modular.
that helped
Yep.
drive the adoption
Yeah,
of your stuff. Yeah,
yeah, yeah.
cool.
It's kind of ironical, right? When you design a system for high scale, right? Of course, it needs to really have an individual per route, low footprint. Otherwise, you cannot really squeeze through the data fast enough, right?
Yeah.
That, interestingly, is also a very good entry ticket for low-end systems like Intel Atom processors because your code runs here very efficient.
No, that's interesting because you wouldn't expect something that can scale super big to run on, on a tiny
No,
little thing,
it was kind of interesting. So we had this database infrastructure, right? An in-memory key value store, public subscribe message bus, all passing data back and forth using shared memory sockets, and this nice plugin architecture, right? All geared for high-speed BGP and ISIS flooding loads. And then one of our first customers really said, "Hey, that's fantastic, right? I really like your system. I can instantly talk now to the core. But would you be willing to implement protocols like PPPoE and L2TP and all of that, right?"
Yeah.
And I mean, my face really turned pale, right? I
Yeah.
said, "Hey, come on. I mean, those protocols are 20 years old, right? All the
Right.
developers
Back to what we said at the
by
beginning,
now,
right?
right? Or retired." So,
Yeah.
but what was very surprising to us is that we could actually use the core machinery of what we have built for BGP and just port it forward to do those protocols as well. And we got instantly decent scale. When we previously have been sharding BGP paths, we were now sharding subscriber management sessions. And then we knew, hey, we're onto something.
You're
right?
onto something there. Yeah. No, that's cool.
That's a
Cool.
little
Well,
bit
Hannes,
that old recommendation from Yakov, right? If you find the technology and useful in a place that it not originally has been designed for, then it's a sign of success here.
yeah, no, for sure. And also making it functional over there too, which is the other
Yeah.
trick too, Yeah.
So here is, a poster reprint of RFC 1925, right? On the back of my wall, right? Rule number one, it has to work.
It has to work, right? Sage advice, but obvious, but sage advice for everybody, right? Cool. Well, Hannes, we're running up against the top of the hour. Do you have any parting words for our listeners before we wrap it up?
I would say 2021 is the year when disaggregation finally will get deployed, so don't miss it.
Oh, cool. Well, I wanted to thank you for being on. And one last bit of housekeeping just for our listeners. T1 Nexus has agreed to sponsor our podcast and help us sort of pay for the infrastructure we need to run this show every week. So I wanted to give them a shout out. You'll all be seeing, their tagline and whatnot in our future programming. But I'll just read their tagline today: T1 Nexus, OEM compatible, SFP, QSFP DACs, and AOCs, and their easy coder optical transceiver encoding platform. So please check them out and please sponsor our sponsor. Again, Hannes, thank you for being on again. I love having you on, and hopefully we'll have you on again in the near future. Thank you very much.
Lovely, thank you. And by the way, your T1 Nexus system, of course, will run in our RG brick power system.
I hope so.
Beautiful.
Thanks a lot, man, and take care.
All right.